I am Dr. T. Vijaya Gowri, working as Associate Professor in Department of Civil Engineering, Vijaya Institute of Technology, Narsapur. Course name is Railways, Airports and Harbour Engineering, and today's topic name is Airport Surface Drainage Design. Airport drainage design is very important and also it facilitates to drain storm water immediately from the runway surface and also to avoid disintegration of pavement surface due to the stagnation of water. Firstly, we are going to see objectives of surface drainage design. The first objective is removal of surface runoff resulting from selected design storm without damage is considered. The possibilities of removal of surface runoff from the storms greater than design storm with minimum damage is considered. Maximum reliability of operations practicable under all climatic conditions is estimated. Minimum maintenance and operation difficulties and expenses are also observed. Adaptability to future expenses and interruption of normal traffic is also considered. Some of the factors also need to be considered in this estimation of runoff. Those are the condition of soil affecting infiltration. This is based on the different types of soil, and gravel sandy, sandy loam, sandy clay soils are self-drained soils. At that particular soils, the runoff may be less. Temperature of air, water, soil. The temperature increases, the runoff may be reduces because the evaporation of water. Extent and condition of the vegetation cover. The vegetation increases, then the runoff will be reduces. The pervious or impervious surface. Impervious surface is increases, the runoff is also increases. Slope of surface generally increases the runoff. Moisture content of the soil is also increases the runoff. Airport drainage can be estimated by using the following expression. Q is equal to CIA. C is the coefficient of runoff resulting from the ratio of runoff to the rainfall. Q is the runoff is cubic meters per second and drainage area is A in 100 square meters. I is intensity of rainfall in mm per second for the time of concentration. So, now we are going to see the parameters used in the surface drainage design and also how do we calculate those parameters. The time of concentration is defined as time taken by the storm water to reach the drain inlet from the farthest point in a tributary. This is consisting of two components, that is inlet time and time of flow. We can write it as time of concentration is equal to time of inlet plus time of flow. So, here the inlet time is time taken by the storm water which is located from the farthest remote point to the drain inlet is known as time of inlet. From the time of flow is the time during which the water flows through the drainage system to the point concentration. From here to here, the time taken by the storm water to reach this particular point is known as time of flow. So, the time of concentration is the time taken by the storm water from the most remote point to the point of concentration is known as time of concentration. For runways, the drainage inlets are going to be placed like this in different places, drainage inlets, and some outfall is going to be some outfall is going to be placed here. So we are going to identify the remote point or farthest point from the inlet, and the inlet time is time taken by the storm water from this particular point to drain inlet is the time of inlet. The time taken by the storm water passing through this particular drainage system to this particular outfall is known as time of flow. So, time of inlet is obtained roughly from the empirical relationship as follows: d is equal to kt square. D is the distance in meter, t is the inlet time in minutes, and k is dimensionless empirical factor which depends on slope, roughness of terrain, extension of vegetation cover, and distance to the drain inlet. The inlet can be obtained from the figure, this particular figure. So here the distance in minutes, distance in meters, and also they have considered the pavement roughness and vegetation cover and slope of the ground is also considered. So this figure gives the inlet time for the storm water. So the time of flow is also find out by dividing the total length of the drain pipe divided by the velocity of the flow. So here this picture resembles to calculate the inlet time of that particular storm water. So distance here we cover these curves are covering this distance in meters, and pavement, smoothness of pavement. Here C is increases more for the impervious layers. If grass is keep on increasing, so C value, coefficient of runoff, is going to be reducing. Here if you observe this one, the slope, if you see slope, we are taking the inlet time is go on increases, and slope is increases, the inlet time is reduces where the runoff is increasing. Next, calculation of the coefficient of runoff. So coefficient of runoff is depending upon pervious condition, slope, surface porosity of the soil, extent of drainage area. So FAR suggested this table for coefficient of runoff C based on the type of the surface. There are different types of surfaces of the runway pavement, that is watertight roof surface, bituminous runway pavements, cement concrete runway pavements, gravel, macadam pavements, impervious soils with turf, and slightly pervious soil with turf, moderately pervious soils, So there have been given different factors for the different types of soils. So that the entire drainage area consisting of several types of surfaces through which the storm water is flowing to the drainage inlet. So we have to consider all the factors of that particular surface characteristics, and also we have to estimate the length which is passed through that different types of surfaces and their runoff coefficients and the area through which it is passing. Considering all the different areas from the runway pavement to the inlet, drainage inlet, so we calculated some coefficient of runoff, one coefficient of runoff for total drainage area, that will be calculated. C is equal to A1 plus A1 into C1 plus A2 C2 plus A3 C3 plus so on, and divided by A1 plus A2 plus A3 plus so on. So where A1, A2, A3 and so on are the area of different types of surfaces, and C1, C2, C3 are the respective coefficient of runoff. Now we see some design, general design principles for surface drainage design. So each pipe is designed to carry the discharge from the inlet at the upstream end plus the contribution through all the preceding inlets. From the economical consideration, grade of each drainage line is fixed studying the natural topography. The minimum mean velocity of 0.75 meters per second is maintained to prevent the scouring. The diameter of the storm drain not less than 30 centimeters to ensure adequate cross section for flow at all times. The inlet is located at a distance not less than 22.5 meters from the edges of the pavement. If there exists a taxiway parallel to the runway, the inlets are placed between the valley, between the runway and taxiway. However, the aprons, the inlets are usually placed on the pavement. This is the only way by which the large area of apron can be drained efficiently. The drain inlets are placed 60 to 120 meters apart in case of the ponding and 52.5 meters in case of the no ponding condition. So, here this picture shows the recommended drainage or layout for the runway. Here this is the plan for, this is the runway, this is the center of runway and this is the runway and this is the drainage inlets here are placed. This is the outfall. So the drainage inlets are placed at a distance between the 60 to 120 meters and from the edge of the pavement to the drainage line, drainage inlets are provided at least 22.5 meters from the edge of the pavement. This is the cross section of AA. Here this is the 45 meters is the width of the runway and here the mentioned slope and this is here 1.5% and this is the inlet manhole. So the time of inlet is nothing but the time taken by the storm water from the most remote point to the inlet of manhole. And in case of taxiway running placed parallel to the runway, then a valley is going to be placed here, constructed here, and also in these drainage inlets are going to be placed in the valley in between the runway and taxiway. So next, design procedure. First, identify the structures and establish the length of the pipe segments between the structures with sufficient accuracy. So, selected the values of coefficient of runoff for all types of surfaces over which the water would flow. Then compute the weighted values of C and calculate using the formula for that. And determine the distance from the inlet to the most distant point in the tribute subarea. If the flowing through such point, water transfers different types of surfaces and length of the flow over each type of the surface is going to be determined. Using the distances which is calculated in step 4. So, and topographical drawings, the time of flow to the inlet most distance point is to be established. The time is determined is inlet time. It will be calculated from the 14.7 that inlet curves which is established from the many experiments for the airport surface design. So here this is we know the length distances and we know the different types of surfaces on which the water would flow. So we identified and we calculated all the inlet time and we added and then we will calculate the inlet time. The time of flow will be calculated, the total length of the pipes divided by velocity of flow in that particular pipes will be calculated. Then adding the both time of inlet and time of flow, we will calculate time of concentration. So determine the time of concentration. Then using the diagram, we also identify the rainfall intensity, the corresponding to the time of concentration. This is the intensity duration curves. FAR design procedure is based on 5-year frequency storm. In this graph, we have seen there are many frequency graphs are there. 50-year frequency, 25 years, 10 years, 5 years, 2 years frequency. In this FAR design procedure, consider 5 years frequency storm. So this graph is based on the duration of the storm and intensity of rainfall. I will be calculated from this. Duration means nothing but time of concentration, which is nothing but time of inlet plus time of flow. So from this, interpolate in this and find out the intensity of rainfall mm per hour. So using that, I see and we know the area and find out the quantity of runoff by using the formula Q is equal to CIA. So next, this is the amount of water which the effluent pipe must accommodate. So for that, we use the Manning's formula. Q is equal to A into R to the power of 2 by 3 S to the power of half divided by N cubic meter per second, where Q is the quantity of water for given size drain would carry a cubic meter per second. A is the cross-sectional area of the drain in square meter and R is the hydraulic radius in meters, that is equal to area of cross-section of drain pipe divided by wetted perimeter of the drain pipe. This is depending on type of cross-section of pipe. And N is the coefficient of roughness. This is the roughness is depending on the type of material used for the pipe. Then these two things is equating these two values and find out the diameter of the pipe for the inlet. So this is the way we have to design for all the pipes and find out the drainage system. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.